As said, the thrown angle is A. We have tan A equals 5 over 12, 12 over 13. Sine A, so cos A is 12 over 13, sine A is 5 over 13. This all comes from this piece of information here. The plane is inclined at, the plane itself is inclined at 45 degrees to the horizontal. So that makes that angle B is sine 45. So that means that sine B is 1 over root 2. Cos B also equals to 1 over root 2. So we have both 1 over root 2's here. The plane projection is spherical and contains the line of greatest slope. That just means it's a standard question, okay? So what we're going to do next is we're going to work with our phi x, phi y, these equations here. I'll bring them down. Just remember that they're all negative this time. Okay? Negative and negative. So let's find our phi x. Phi x is going to be u. What's u in this case? U is 13u. So 13u cos alpha, which is 12 over 13, minus gt, and then it's going to be 1 over root 2. Okay, and what that's going to get me is 12u minus gt over root 2. That's your phi x. Your phi y is going to be 13u times sine y, which is 5 over 13, minus gt times 1 over root 2, because it's gt cos b. Phi y is going to get me 5u minus gt over root 2. Once I find the two, the phi x and the phi y, what can we say about the sx and the sy? Oh no, I wrote that the wrong one. There we go. So get rid of the top one, the middle one, and there we go. So there's our phi x and phi y there. Now, what can we say about the sx and sy now? Anybody tell me? Sx is? Add on a t. Yeah. Half it, so it's going to be gt squared. The root 2 was there already. It's going to be another 2 there. Okay. Then the sy. The sy, lads. 5ut minus gt squared 2 root 2. Okay. Once you have it prepared, now and only now are you actually ready to pretty much see exactly what you're looking for and tackle the question. So, the particle next strikes the plane at point P, which is up here. If the coefficient of restitution between the ball and the plane is 2/5, show that the particle rises vertically from P. What does rises vertically mean? They're talking that rises vertically. They'd have to specify rises vertically to the angle of the inclined plane. Rises vertically after the second bounce will have to be straight up like that. Okay? For that to occur, we'd need another 45-degree angle here, wouldn't we? Because both angles added together would turn it a complete 90 degrees. So we're looking to prove that the rebound angle is 45 degrees. So that's what we're in essence trying to do here. To prove that rebound angle is 45 degrees. Okay? So what we're going to do next is we're going to, first of all, can anybody describe the steps we need to do? We need to find what is our phi x and phi y just before collision. Yeah? So we're going to find our phi x and our phi y just before collision. So just before, if you imagine this is the plane and we're coming in, we'll use a red line to indicate on the way in. Or will we? Sorry, this line here. You have a red line on, black line on the way in, and then on the way out, you're going to have a red line on the way out. That's before and after collision, okay? So it's your phi x is going across and your phi y is on its way down. What do you know about the way out? Phi x is unaffected, but there's a new phi y, isn't there? The phi y is e times phi y, or minus e times phi y. It changes direction and it's affected by the coefficient of restitution. Okay. So what we're going to do next is this. Okay. Just give me a second. So first of all, to find these, we did this in the last question. To find the speeds just before impact, what do we need to do first? We need to solve sy equals 0 to find what? Find time of flight. So solve sy equal to 0. So what you're going to get is 5ut equals gt squared over 2 root 2. T cancels with that t there. You're going to get 10 root 2 u over g equals t. Okay, so you can see it's sort of an abstract question. It's all in terms of u. Okay. Once we've done that, we're going to put it into the phi x and phi y equation. Okay, so we'll start off with phi y because I can actually see what phi y is. Phi y equals 5u minus g over root 2 multiplied by t, which is 10 root 2 u all over g. G's will cancel, root u's will cancel, and as predicted, phi y is negative and going into the plane. So phi y being negative and driving into the plane. Okay, so it's going to be 5u minus 10u, which gives phi y minus 5u. Okay, now that we know that's minus 5u, we're just going to look up at phi x here, put it in range. So it's 12u. The only difference is it's 12u. Okay, so phi x is 12u minus g over root 2 times t. We know that t is 10 root u, 10 root 2 u over g. The g's will cancel, the root 2's will cancel. 12u minus 10u, 2u, isn't it? Okay. Phi x equals 2u. Now, here's our picture just before collision. Just before our impact, we're coming in and we're on our way out. We're coming in at 2u to the right, which means immediately after impact, like I'm literally talking a billionth of a second after impact, before gravity starts affecting it again, you're going to be going 2u on your way out. Okay? Your minus 5u on your way down is affected by the coefficient of restitution, which is 2/5. So what's 2/5 of 5? 2/5 of 5u, anybody? Huh? 2u on the way up, isn't it? Now, this angle here, the opposite and the adjacent are the same value, which means it's automatically 45 degrees. Now, the angle, you're already inclined at 45 degrees. If you travel parallel to this axis, you're already traveling at 45 degrees. You now have another 45 degrees on top of that. So 45 degrees plus 45 degrees means you're traveling at 90 degrees relative to flat ground. Hence, your particle rises vertically from P. Is that alright? Okey dokes.